Hello and welcome! Today I'm going to show you how I took my old failing LCD monitor and turned it into a nice bright light panel that will be perfect for making videos or taking pictures. So without further ado, let's go ahead and get into it. The first thing I did was go around the back of the monitor and try to locate any screws that would be holding the panel on. This was easier said than done. Unfortunately, I missed a couple of important screws that, after prying for a while and not being able to figure out why it wouldn't come off, I had to go back and take out.
I missed a screw.
Luckily, after I took out the screws I had missed, I was able to get the front panel of the display to come off with just a little pressure near each of the plastic clips that helped hold it together.
The display. Ta-da! Alright, let's see here.
After I pulled the LCD display out, I needed to get to the LCD itself. To do that, I had to go around the sides and pry loose each of these little metal clips in order to get access to the individual parts of the LCD.
Whoop. Well, I guess that works. There's the LCD. Wasn't quite ready for the whole friggin' LCD to got balls. Come out. Ugh. Why is that tape black? I don't know. But I'm sure we'll find out. Backlight, LCD panel. Whoa. Okay. Ha ha ha! That was actually way easier than I was expecting. This LCD should still work. Can't see through it though. Put the front cover back on.
Once I had the LCD out, I screwed the small back panel in and reinstalled the front of the metal case so I could plug the backlight in and test to see what voltage the backlights needed.
I'm gonna electrocute myself. Oh, I think it's on. Oh, I think it's on. Oh, yes, it is on. Oh, that is, wow. That is messing with my camera. I don't know if it's actually recording that or not. The problem is, though, is that the power supply is going out on this. So I need to figure out what the voltage it's sending to the LEDs. Set it on 200 volts just to be safe, but I don't think it's sending that much to the LEDs. 12 volts, 16.5 volts, 50 volts, 50 volts, 12 volts, 16 volts, yep.
After I finished testing the voltages, I was kind of confused as to why the LED backlight needed 50 volts. That seemed like way more voltage than a few LEDs would need. I decided I needed to pull the rest of the parts out and look at the circuit board to determine how the LEDs were hooked up in order to figure out how I was going to power them.
Damn it. Well, I guess I got that. What is this? A polarizing filter or something? Oh, no, I don't know what it is. Whoa. Dang it. I broke the plastic. Oh my gosh. I can't believe I broke that. Whatever. All right, where are my LEDs here? Okay, so I didn't realize there was another, some other filters in there. So there's this, like, interesting thing. It looks like some kind of like refraction grating or something. So I don't think I need that for the light panel, so we'll take that out. So then this is basically the light diffusion panel itself in the LED. So, oh golly. So it actually apparently has two diffusion filters. So there's this diffusion filter. So, and then I take that off and there's another diffusion filter. So then there's that diffusion filter here. And then if you look, in there is the plexiglass, or the acrylic, that has a bunch of dots etched in it to actually reflect the light to the front of the screen. So I think for the light panel, all we need, well, and of course this back piece that helps reflect the light forward. So for our light panel, I think we'll only need the two diffraction gratings on the front, and then this reflective grating on the back to make sure the light comes out the front. I don't think we need that diffraction grating though that I pulled out. I think that was more for the LCD than for the backlight. So we don't have to worry about that. we just need to move that stuff aside, and we have got our LEDs. So here's the LED strip in there. So I just need to figure out why it's wired the way it is, or why it needs 50 friggin' volts to power this up, and see if I can find another way to power this up that doesn't need 50 volts. Those are bright. Wow.
Now it was time to pull the circuit board for the backlight out of the case. It was held in with some double-sided sticky tape of some sort. I carefully pried the board up, trying not to bend it too much. And I didn't realize it was an aluminum circuit board until about halfway through removing it. After removing the circuit board and testing the LEDs a little bit, I decided it would be way easier to just use a regular 12-volt LED strip instead of trying to modify the original circuit board to work on 12 volts. So I decided to give it a try. It took a lot more work than I thought it would to get the LED strip to stay in place as I tried to get it to fit. Once I got the strip in, I put the panel back together to see if it would work.
Oh, if I run it at almost 14 volts, it lights me up pretty good. Maybe I should try some higher power LEDs or something. Woo! Oh, balls. Don't tell me it burnt the LED strip out. Oh, good. Okay, it was only for a second. I don't know what voltage that jumped to, but holy smokes. I thought I fried it. Weedo.
After testing it with the 12-volt strip, I decided it just wasn't quite as bright as the original LEDs. It was time to modify the original LED's circuit board so that it would run on 12 volts instead of 50. After looking at the circuit board, I was able to determine that the LEDs were wired in 3 groups of 15, with each LED needing around 3 volts to reach full brightness. That would explain why the power supply was sending 50 volts to the LED strip. So what I needed to do was modify the circuit board to run the LEDs as 11 sets of 4 so that I could power them with 12 volts. With that figured out, it was time to get to work. Using a razor blade, I made notches in the circuit board to isolate each group of 4 LEDs from the others. This was a very tedious process that took way longer than I thought it would. The next thing I had to do was solder some of the LEDs together where the original groups of 15 were separated. Then I went through and scraped off the enamel over the copper and tinned each spot so I could go through and add the power and ground wires. Then it was time to get all the wires soldered onto the circuit board. This ended up taking me almost 2 hours to get everything wired up. Needless to say, I was done soldering for a while after this project.
Okay, now, after 2 hours freaking soldering, I can test it, and this whole LED strip should now run on 12 volts instead of 56. Oh my goodness. All right, come here. You gonna help Dad test it? See if it runs on 12 volts like I'm hoping it will. Uh-oh. I think we have a short. Ooh, that's hot. Yeah, we've got a short somewhere.
So for some reason, the audio just glitched out on this clip, but after going through and checking all my solder joints, I found a couple of them that had shorted. So once I got those fixed, plugged it in, and as you can see, it was working great. Now that I finally had the original circuit board working on the voltage that I wanted, it was time to go back and take this old LED strip out, and I didn't want to waste it, so I tried to roll it up as I pulled it out so I can hopefully use it for a future project. Once I had that out, it was time to put the original LED strip back in and all the rest of the parts of the LCD screen. Unsurprisingly, all the different parts of the backlight fit much better in the metal case with the original circuit board than they did with the 12-volt LED strip that I had to run all the way around.
I guess I better test it before I add anything else. So let's hook it up. Oh, balls. It's not lighting up. Why is it not lighting up? Why are you not working now? Something shorted. Oh, no, that's not a short. That's an open. It's not drawing any current. Gosh, fine. 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 How the freak did those come off? My power and ground wire just came off. Yep, that would be why I freaking smashed them.
Apparently, it was the original plug on the circuit board that smashed them, so I pulled it off.
So this time, before trying to put the plastic bag on, I'm going to, where are my wires? Oh, I unplugged my power supply. Oh, yes. Success. Here, check this out. It is working. It's running on 12 volts. Now I can put the plastic back on.
I also added a 2.5 centimeter jack on the back of the TV through one of the video ports for me to be able to plug my 12 volt wall adapter into. And with that, my light panel was now finished.
This thing is so freaking bright.
Look at it. Oh, it works. It's actually pretty bright, considering what it is. All right, and just to show you what it looks like from my point of view over here, so there's the light panel. And it's actually lighting it up pretty good down here. Well, sweet. Well, I would definitely consider that project a success. I mean, that's the only light I have on down here. But that's it for this video. Thank you so much for watching. Don't forget to leave a thumbs up if you enjoyed the project. And if you have any suggestions or just want to comment, leave a comment below. It does help the channel out a ton and makes it so I am able to do more videos like this. So please do that if you enjoyed it. But thank you so much for watching. And I will see you in the next video. Bye.